Hey everyone and welcome. Have you ever wondered how your favorite game keeps track of your high score? Or, how a simple text editor actually saves your work so you can come back to it later? Well, it's all about giving our programs a memory. And today, we're going to dive into how we can stop our C programs from being so darn forgetful and teach them how to save information for good. So let's start with the core problem, right? You write this amazing program, it runs, it does all this cool stuff, and then you close it. And poof, everything's just gone. All your data, every result, it all just vanishes into thin air. So why does that happen? Well, it's because by default, all that information is living in temporary memory, which gets totally wiped clean the second that program shuts down. So what's the fix for this program amnesia? Well, it's actually a beautifully simple solution, a file. Just think of a file like a dedicated notebook for your program. It's a spot on your computer's hard drive where you can write down information you need to keep, long after the program itself has closed. It is the absolute key to permanent storage. But using files is about more than just solving that memory problem. Sure, permanent storage is the big one, but they also make sharing data super easy. One program can write a file, and a completely different program can come along and read it. And trust me, when you start dealing with huge amounts of data, files become absolutely essential for keeping everything organized and easy to find. And look, this isn't just some abstract, dusty computer science concept. File handling is kind of like the invisible engine humming away behind so many of the apps you use every single day. Let's look at a few examples I guarantee you'll recognize. You know when you set your favorite theme in an application, or maybe change the font size? Yep, that's saved in a file. When you finally beat that tough level and the game saves your progress, it's writing to a file. Even simple databases, like a customer list for a small business or an inventory tracker, are often just managed with files. They are the true backbone of keeping your data around. Okay, so we're sold. We need files. But it's not quite that simple. Just like picking the right tool for a job, we have to choose the right kind of file. And in the world of C programming, that choice usually boils down to two main flavors: text files and binary files. The best way to think about the difference is with an analogy. A text file? That's like a simple notebook. You can open it up and you can read it yourself. It's perfect for things like configuration settings or log files. A binary file, though, that's more like a complex blueprint. It's not really meant for human eyes. It's a super efficient, compact way for the computer to store complex data like images, audio, or even compiled code. The big trade-off is this. Text files are universal and easy to work with, but they can be a bit slow. Binary files are lightning fast for the computer, but they might not be readable if you move them to a different kind of system. All right, so we get the what and the why. Now let's get to the fun part, the how. How do we actually start working with these files in our C code? Well, thankfully, C gives us a really powerful and honestly pretty straightforward toolkit to get the job done. The one magic key that unlocks all this power is this little line right here, including the stdio.h library. It stands for Standard Input/Output, and it's the foundation for pretty much any C program that needs to talk to the outside world, whether that's the screen, the keyboard, or, in our case, files. This library is your gateway to everything we're about to do. So what's actually inside this library? Well, it gives us a core set of functions. These are our tools for messing with files. We can kind of think of them in a few logical groups. So let's take a quick little tour. First things first, you always have to open a file before you can use it, and you have to close it when you're done. That's what fopen and fclose are for. Now, if you're writing structured data, like a mix of text and numbers for user profile, you're going to use fprintf and fscanf. If you need to process a file one single character at a time, maybe for some simple encryption, you've got fgetc and fputc. And for handling whole lines of text at once, like reading a config file, you've got fgets and fputs. See? Each tool has its own specific, powerful job. So here's the really crucial takeaway from all this. It doesn't take a mountain of complicated code. With just this handful of basic functions, you have everything you need to build applications that don't just run and then forget everything. You can create programs that actually remember user preferences, that save progress, and that manage data over time. In other words, they can grow and they can persist. So there you have it. We've seen why programs forget, how files give them a memory, and we've toured the basic C tools you need to make it all happen. You now have the fundamental knowledge to create programs that actually leave a mark. So, the only question left is, now that you've got the tools, what are you going to build that lasts?